Hello friends, welcome to UGC PG program. I am Dr. Ushvinder Kaur from Swami Shraddhanand College, University of Delhi. To introduce, water is absolutely essential for sustaining life on earth. Water has a unique place among all the planet's renewable resources. It is vital for food production, economic development and for general well-being. Water resource of a country constitute one of its vital assets. Water is truly unique as there is no substitute for this resource. The earth can be perceived as a water planet as about 71% of earth's surface is covered with water. The oceans hold about 96.5% of all earth's water. Water also exists in air as water vapor, in rivers and lakes, in ice caps and glaciers, in the ground as soil moisture and in aquifers, and even in human beings and other organisms. Water is never still and our planet's water supply is constantly moving from one place to another and from one form to another through water cycle. The vast majority of water on the earth's surface, over 96%, is saline water found in oceans. The freshwater resources such as water falling as precipitation and moving into streams, rivers, lakes and groundwater provide us with water needed for everyday use. However, there is much more fresh water stored in ground than there is in liquid form on the surface. Where is Earth's water located? The total volume of Earth's water on Earth is about 1400 million cubic kilometer, of which only 2.5% or about 35 million cubic kilometer is fresh water. Most fresh water occurs in form of permanent ice or snow located in Antarctica and Greenland and in deep groundwater aquifers. The principal source of water for human use are lakes, rivers, soil, moisture and relatively shallow groundwater basins. The usable portion of these resources is only about 2 lakh cubic kilometers of water, less than 1% of all fresh water, only 0.01% of all water on earth. Much of which is available water is located far from human populations, further complicating issues of water use. The replenishment of fresh water depends on evaporation from surface of the oceans. About 5,05,000 cubic kilometers or a layer of 1.4 meter evaporates from oceans annually. Another 72,000 cubic kilometers evaporate from the land. About 80% of all precipitation, around 4,58,000 cubic kilometers per year, falls on the oceans and remaining 1,19,000 cubic kilometer per year on land. The difference between precipitation on land surfaces and evaporation from these surfaces, that is 1,19,000 cubic kilometer minus 72,000 cubic kilometers annually, is runoff, and groundwater recharge, which is approximately 47,000 cubic kilometer annually. The figure opposite shows one estimate of average water balance of major continental areas, including precipitation, evaporation and runoff. More than one half of all runoff occurs in Asia and South America, and large fraction occurs in a single river, the Amazon, which carries more than 6,000 cubic kilometers of water a year. Distribution of world's fresh water resources. Glaciers and ice caps cover about 10% of world's landmass. These are concentrated in Greenland and Antarctica and containing more than 70% of world's fresh water. Unfortunately, most of these resources are located far from human habitation and are not readily accessible for our use. According to United States Geological Survey, 96% of world's frozen freshwater is at South and North Poles, with the remaining 4% spread over 5,50,000 square kilometer of glaciers and mountainous ice cap measuring about 1,80,000 cubic kilometers. Groundwater is by far the most abundant and readily available source of fresh water, followed by lakes, reservoirs, rivers and wetlands. Groundwater represents 90% of world's readily available fresh water resources. Most freshwater lakes are located at high altitudes, with nearly 50% of world's lakes located in Canada alone. Many lakes, especially those in arid regions, become salty through evaporation. Reservoirs are artificial lakes produced by constructing physical barriers across flowing rivers, which allow the water to pool and to be used for various purposes. The volume of water stored in reservoirs worldwide is estimated at 4,286 cubic kilometer. Wetlands are other significant sources of fresh water, which include swamps, bogs, marshes, mires, lagoons and floodplains. 10 largest wetlands in the world by area are West Siberian lowland, Amazon River, Hudson Bay lowlands, Pantanal, Upper River Nile, Cherry Long River, Hudson Bay lowlands in South Pacific, Congo River, Upper Mackenzie River, North American prairies, potholes. The total global area of wetland is estimated to be 29 lakh square kilometer. Water cycle. Without water, the other nutrient cycles would not exist in their present form and current forms of life on the earth, which consists mostly of water containing cells and tissues, could not exist. The hydrological cycle or water cycle collects, purifies and distributes Earth's fixed supply of water. The main process in this water recycling and purifying cycle are evaporation, the conversion of water into water vapor; transpiration, evaporation from leaves of water extracted from soil by roots and transported throughout the plant; condensation, conservation of water vapor into droplets of liquid water; precipitation, rain, sleet, hail and snow; infiltration, movement of water into soil; percolation, downward flow of water through soil and permeable rock formations to groundwater storage areas called aquifers; runoff, downslope surface movement back to the sea to resume the cycle. The water cycle is powered by energy from sun and by gravity. Incoming solar energy evaporates water from oceans, streams, lakes, soil and vegetation. About 84% of water vapor in the atmosphere comes from oceans and rest comes from land. The capacity of air to hold water vapor depends on its temperature. Warm air can hold more water vapor than cold air. Wind and air masses transport water vapor over various parts of the Earth's surface, often over long distances. Falling temperature causes the water vapor to condense into tiny droplets that form clouds or fog. For precipitation to occur, air must contain condensation nuclei, which are tiny particles on which droplets of water vapor can collect. Volcanic ash, soil dust, smoke, sea salts and particulate matter emitted by factory, coal burning power plants and vehicles are sources of such particles. The temperature at which condensation occurs is called dew point. Some of the fresh water returning to the Earth's surface as precipitation gets locked in glaciers. Most of the precipitation falling on terrestrial ecosystem becomes surface runoff, flowing into the streams and lakes, which eventually carry water back to the ocean, where it can be evaporated to begin the cycle again. Water not only replenishes streams and lakes, surface runoff can cause soil erosion and moves soil and weathered rock fragments from one place to another. Some of the water returning to the land soaks into or infiltrates the soil and the porous rocks and then percolates downward, dissolving minerals from porous rocks on the way. This water gets stored in the pores and cracks of the rocks. Where the pores are joined, a network of water channels allows water to flow through the porous rock. Such water-laden rocks is called an aquifer, and the level of Earth's land crust to which it is filled is called water table. This underground water flows slowly downhill through the rock pores and seeps into streams, the lakes, or comes out into the form of springs. Eventually, this water evaporates or reaches the sea to continue the cycle. Throughout the hydrological cycle, many natural processes act to purify water. Evaporation and subsequent precipitation act as a natural distillation process that removes impurities dissolved in water. As water flows above the ground through the streams and lakes and below the ground in aquifers, it is naturally filtered and purified by chemical and biological processes. Thus, the hydrological cycle also acts as a cycle of natural renewal of water quality. Water is transported in different forms within the hydrological cycle or water cycle. Estimated that each year about 5,28,000 cubic kilometers of water evaporates over the ocean and seas, 90% of which returns directly to the oceans through precipitation, while the remaining falls over the land, with evapotranspiration totaling about 7,42,000 cubic kilometers. The total volume in the terrestrial hydrological cycle is about 1,19,000 cubic kilometers. About 35% of this, or 44,800 cubic kilometers, is returned to oceans as runoff from rivers, groundwater and glaciers. A considerable portion of river flow and the groundwater percolation never reaches the ocean, having evaporated internal runoff areas or inland basins, lacking an outlet to the ocean. However, some groundwater that bypasses the river system reaches the ocean. Annually, the hydrological cycle circulates 5,77,000 cubic kilometers of water. Water resources in India. With the increasing population of India, there is an ever increasing demand for water resources. On an average, India receives annual precipitation of about 4,000 cubic kilometers. However, there exists considerable spatial and temporal variations in the distribution of rainfall across the country. Consequently, the availability of water also varies considerably. It is estimated that out of 4,000 cubic kilometers water, 1,869 cubic kilometer is the average annual potential flow in rivers available as water resources. Out of this total available water resource, only 1,123 cubic kilometer is potentially usable. That is 690 cubic kilometers from surface water resource and 433 cubic kilometers from groundwater resources. India, with a geographical area of about 329 million hectare, can be divided into 7 well-defined physiographic regions. These include northern plains comprising mighty Himalayan range and the Great Plains transferred by Indus, Ganga and Brahmaputra river systems, the central highlands consisting of wide belt of hills running east-west between the Great Plains and the Deccan Plateau, the Peninsular Plateau, the east coast, the west coast and the islands comprising Lakshadweep in Andaman Sea and Andaman and Nicobar group of islands in Bay of Bengal. India has a variety of climatic zones which range from extreme of heat to extreme of cold, from extreme aridity to negligible rainfall to excessive humidity and torrential rainfall. Most of the rainfall in India takes place under the influence of southwest monsoon between June to September, except in Tamil Nadu where it is under the influence of northeast monsoon during the October and November months. The average rainfall is about 1,215 millimeters. However, there is a considerable spatial variation in rainfall which ranges from less than 100 millimeters in western Rajasthan to more than 2,500 millimeters in northeastern areas. India is blessed with many rivers. A river basin, also called catchment area of the river, is the area from which rain will flow into that particular river, and the shape and size of the river basin is determined by the topography of the area. River basin is considered as a basic hydrological unit for planning and for development of water resources. There are 12 major river basins with a catchment of about 20,000 square kilometer and above. The total catchment area of these rivers is 25.3 lakh square kilometer. The largest river basin is Ganga Brahmaputra Meghna with catchment area of about 11 lakh square kilometers. The other major river basin with a catchment area of more than 1 lakh square kilometers are Indus, Mahanadi, Godavari and Krishna. There are 46 medium river basins with the catchment area ranging between 2000 to 20,000 square kilometer. The total catchment area of medium river basins is about 2.5 lakh square kilometer. All these river basins cover about 81% of geographical area of the country. Problems of surface water resources. Water is an essential part of any ecosystem. Any change in the availability and quality of water would have a devastating effect on the natural environment. Climatic change is fueled both by emissions and the degradation of world's natural environment. Increasing number and intensity of natural disasters are directly resulting in degrading environment. Climate change is often blamed for increasing the number of floods and droughts. Our natural environment has the capacity to cope with pollution and degradation to a certain extent. But when these capacities are exceeded, it can result in irrepressible contamination, which in turn can lead to destruction of ecosystems. Surface water resources are renewable, but only within a clear limit. Water resources also vary over space and time, as there are vast differences in availability of water resources in various parts of the world and huge differences in amount of seasonal and annual precipitation. Our water resources are facing rapid pollution, mostly due to human waste, with 2 million tons a day disposed into water courses. Industrial wastes and chemicals, and agricultural and pesticides and fertilizers. Over the last 200 years, human activities such as urban and industrial development and intensification of agricultural practices has unprecedented effect on the water bodies. There are global problems such as heavy metals, regional problems like acid rain, and much more localized ones such as groundwater contamination. In many places, groundwater has become contaminated as a result of leakage from storage tanks, mine tailing, and accidental spillage. Organic pollutants. Organic pollutants are materials from domestic sewage, municipal waste, and agro-industrial effluents in most widespread pollutants globally. These pollutants are discharged untreated into the river, lakes, and aquifers, contaminating the water bodies. Densely populated parts of Asia, Africa, and South America are mostly affected by this type of pollution. This organic material has high concentrations of nutrients, particularly nitrogen and phosphorus. Increase in these nutrients cause eutrophication of lakes and reservoirs, which in turn promotes abnormal plant growth and depleting oxygen levels. Nitrogen levels have also risen due to increased use of nitrogen containing fertilizers in agriculture. There is a matter of concern as nitrate concentration in large numbers of source of river surface water and groundwater exceeds the WHO guidelines of 10 milligrams per liter. In many parts of the world, heavy metal concentrations in river waters have risen due to leaching from waste dumps, mine drainage, and melting. Acidification of water bodies. Acidification occurs when the capacity of soil or water bodies is resistant or neutralized. Acidifying atmospheric deposition begins to decline. Acidifying components may fall to the ground with rain or snow as wet deposition, or in form of particles or gases as dry deposition. If acid deposition rates increase consistently, ecosystems can eventually lose their neutralizing capacity completely. Acidification of surface water was a serious problem for the developed world during 1960s and 70s, particularly in Scandinavian, West and Central Europe, and in the northeast of North America. However, the sulfur emissions in these regions decreased and the acid rain became a problem which was diminished. Acidification mostly affects aquatic life, which generally cannot survive with pH level below 5. Higher acidity also raises concentrations of metals in drinking water. Acidification is likely to continue in countries and regions with increasing industrialization. For the developing world, increasing salinity is a serious form of water pollution. Arid and semi-arid regions often suffer from increased salinity as a result of poor drainage, fine grain size and high evaporation rates, which led to concentration of salts in water. Sedimentation. Most rivers carry sediments in form of suspended load and bed load. This sediment load is adjusted to the flow regime of the river over time. Increasing or decreasing sediment load can change the flow regime of rivers and cause problems in downstream region. Effects of sedimentation includes reduction of reservoir volumes due to siltation and scroaching of river channels and the deposition of sediments in them, threatening flood protection measures, fisheries and other forms of aquatic life. River diversions including dams can produce some of these effects on sediment. The world total suspended sediment transportation to the oceans is reported to be as high as 51.1 billion tons per year. Salination. The term salinity refers to the concentration of salts in water or soil. Salinity can be in three forms classified by their causes: primary salinity, which is also called as natural salinity; secondary salinity, also called as dryland salinity; and tertiary salinity, which is called as irrigation salinity. Small amounts of dissolved salts in natural waters are vital for the life of aquatic plants and animals. However, changes in salinity can often lead to drastic alterations in marine aquatic ecosystems. Banerjee provides with some important evidence that climate change and the resultant events have led to changes in the levels of salinity in Indian Sundarbans. Over the past 2 decades, the increase in meltwater of Gangotri Glacier in Himalayan ranges due to global warming and Farakka barrage discharges and sea level rise have accelerated such changes. Observations of salinity over a period of 23 years from 1990 to 2012 showed a significant long-term variation. This study shows that increasing melting of Himalayan ice caps might have decreased the salinity at the mouth of Ganga river, where it meets the oceanic water at the western end of deltic complex of Indian subcontinents. Water related disasters. World Water Report 2013 reported that during the time period of 1991 to 2000, over 6,65,000 people died in 2002, 557 natural disasters, 80% of which were water related events. The vast majority of victims, 97%, were from developing countries. Growing concentration of people and increased infrastructure in vulnerable areas such as coast and floodplains and on marginal lands mean that more people are at risk. Asia has fared particularly badly with roughly 40% of all disasters taking place on the continent. Each event leaves thousands of communities more vulnerable to the next disaster. Hence, people are barely able to recover from one disaster before the next catastrophe strikes. Worldwide floods were the most reported disastrous events. The year 2000 saw 153 flood events alone, and some of the worst taking place in Mozambique and along the length of Mekong River in Southeast Asia. While in terms of loss of life, droughts claim the greatest number of victims. According to United States, at least 41 million people in Bangladesh, India and Nepal have been directly affected by flooding and landslides resulting from monsoon rains, which usually begins in June and lasts till September. Water stress in India. India has made significant improvements in both the availability of quality of municipal drinking water systems over the past decades. Still, water resources are under severe stress due to increasing population. Additionally, rapid growth in India's urban areas made the government efforts in improving safe and adequate water becomes inadequate. Regardless of improvements in drinking water, many other water sources are contaminated by pollutants. With over 21% of country's diseases are water related, concerns have been raised that India actually lacks the adequate replenishable water resources for longer periods of time. India's aquifers are currently considered replenishable, but water development rates are also very high in various parts of the country. As a large grain producing country, use of water for agricultural purpose is very high in our country. Water Resource Institute estimate depicts that 54% of India's total area is facing high to extremely high water stress, and almost 600 million people are at higher risk of surface water supply disruptions. Groundwater levels are also declining across India. Of the 4,000 wells captured in IWT 2.0 shows statistically significant trends. 54% dropped over the past 7 years, with 16% declining by more than 1 per meter, that is about 3.2 feet per year. Farmers in arid areas and areas with irregular water supply and rainfall depends heavily on groundwater for irrigation. Government subsidies on farmers' electrical pumps and lack of existing limits to water use have resulted in widespread patterns of excessive water use. Northwestern India is especially vulnerable. Of the 550 wells studied in the region, 58% have declining groundwater levels. At the same time, as much as 13 crore 6 lakh people live in districts where at least one pollutant level exceeding national safety standards in 2011, and more than 20 million people lived in 8 districts where at least 3 pollutants exceeded the safe level. To conclude, keeping in mind the current trends, India is set to become a water scarce country in not too distant future. A rapidly increasing population with ever increasing demand for water, coupled with increasing pollution, overuse in farming activities, and high levels of groundwater exploitation, inadequate governance, and poor infrastructure have severely stressed our water resources. This uneven distribution of the precipitation resulting in highly uneven distribution of available water resources, which leads to floods and droughts affecting vast areas of the country. Utilizing scientific structural and non-structural measures can provide significant in mitigating floods and droughts. There is a need for better management of existing water storages to increase the availability of water resources. At the same time, we can create additional storages by constructing small, medium and large sized dams, keeping in mind the economical, environmental and social aspects. The availability of water resources can be further enhanced by regeneration of dying lakes, ponds and tanks, and also increasing the artificial means of groundwater recharge. Interbasin transfer of water can be crucial measure for mitigating the problems of surplus and deficit basins. Due to rapid industrialization and increasing use of fertilizers and pesticides, the quality of surface and groundwater resources is deteriorating. The movement of pollutants in the rivers, lakes and groundwater aquifers need to be regulated. In this regard, regular water quality monitoring program can go a long way in identifying areas prone to poor water quality. For maintaining the quality of fresh water, water quality management and strategies are required to be evolved and to be implemented. Thank you very much.